This is my cutting-edge chemistry research project. I'll begin with an overview of each category. First is structure and bonding. Within structure and bonding, scientists have made advancements in nanotechnology relating to healthcare and treating patients. This research includes a new antiviral nanoparticle that is designed to be inserted into the body and to lock on to viruses in the body and destroy them. A model of this is shown to the right as the blue nanoparticles are binding onto a virus in the body. Secondly, chemists are also working on a nanoparticle that will emit light inside the body to be able to discover tumors and monitor their growth. And finally, magnetic field lines of bacteria cells and nano-objects have been mapped for the first time. This observation can potentially lead to large advancements in different strands of science, such as nanotechnology engineering. Secondly is energy changes and rates of reaction. Within this category, the research being done involves increasing efficiency of reaction and reducing the amount of energy for various productions. This research includes working on the efficiency of solar cells. Current research shows that incorporating halogens into solar cells can increase their efficiency by up to 25%. Other research shows incorporating the compound guanidium can help increase solar cell efficiency by up to 19%. As a way to use up less energy, scientists are developing a new zeolite that allows separation of ethylene and ethane mixtures by using up to 25% less energy. And finally, in an attempt to turn waste into usable product, research is being done on how to develop ways to convert fossil fuels and biomass into electricity without any CO2 emission. Our next category is chemical systems and equilibriums. Research in this category explores ways to reduce greenhouse gas emission. New technology is being developed by researchers in hopes that we can reduce our greenhouse gas emission by up to 36% by 2050. Also, scientists from the University of York are capturing seawater and scrap metal, which they hope will help them be able to create a technology and prevent up to 850 million tons of CO2 from entering the atmosphere. And finally, scientists from Rice University are developing new asphalt-based filter that will efficiently trap CO2 and prevent it from going up into the atmosphere at natural gas wellheads. Next, we have organic and medicinal chemistry. In this category, a lot of fascinating advancements are being made that could have a large impact on healthcare. Firstly, chemists from Washington State University have developed an injectable dye that illuminates inside the body when it is hit with infrared light. The dye can be used to see inside the body and detect tumors. Secondly, a patch made of brown algae containing microneedles is being developed right now to help people with diabetes, as the chemicals in the needles help regulate insulin levels within the body. And finally, a new dental material textured with an antimicrobial compound is designed to kill bacteria and resist plaque. Our final category is electrochemistry. Research being done in this field mostly involves around new battery technology. This includes research on a non-metal carbon-based electrocatalyst that will be more low-cost and environmentally friendly. Secondly, an all-solid-state lithium battery prototype is being developed instead of the conventional liquid electrolytic solution. This is believed to be a safer alternative that will have a longer charge and could be the future of phone batteries, as they are also much smaller and thinner, as shown in the picture. Thirdly, carbon nanomaterials are being used in place of platinum for cathodes as a cheaper alternative material. Finally, in this category, engineers have created a nano-textured steel surface that kills bacteria using an electrochemical etching process. This can be applied to medical implants and food equipment. Now that all the summaries are complete, I'd like to say that I'm quite surprised and impressed by this research that is being done, as I did not know that most of this existed, nor did I think that most of this was possible. What stood out the most to me was the nanoparticle technology and structure and bonding, and the injectable dye being worked on at Washington State in the organic chemistry. I will now go more in depth behind the chemistry within the organic and medicinal chemistry category. Firstly, the illuminating dye from Washington State is able to glow from the phosphors contained in the dye. Phosphors are a substance that radiate visible light after it has been energized, in this case by the infrared light that is being shown on it. Phosphors are made from what is known as a host material and an activator. The activator helps prolong its light emission. The host materials are typically composed out of oxides, nitrides, sulfides, or other alkali earth metals, while generally the most activator used is nickel. As for the insulin patch, the microneedles inside are glucose responsive. This means that the drug inside, being Excidin-4, is only released when blood sugar levels are above normal. When blood sugar levels are above normal, this leads to a chemical change in the patch that allows Excidin-4 to be released. When Excidin-4 is released into the blood, it stimulates the pancreas to produce insulin. And finally, for the dental material. The dental material is filled with an antibacterial agent known as imidazole. Imidazole is composed of 3 carbons, 4 hydrogens, and 2 nitrogens. It is a heterocyclic aromatic. This means that its ring shape is composed of 2 or more elements, in this case carbon and nitrogen, with the hydrogens bonded on. The picture to the right shows just how strong this antibacterial agent is, as bacteria was able to grow rampant without it present, but was barely able to grow at all when it was. I am personally the most interested within this category, as I have always been interested in healthcare and medicine. I am also quite interested in this research and wanted to learn more about it, as I felt it could have the largest direct impact on people's lives. As for example, the illuminating dye can help discover people's tumors and save their lives, and the insulin patch can help greatly improve the lives of people living with diabetes. I will now go over some research difficulty that these scientists had to overcome or are still dealing with. Firstly, previously tested illuminating dyes from shorter wavelengths would light up blue or green in the body, making them very difficult to see, and the shorter wavelengths damage body cells. But the engineers have now developed a safe dye that is able to be used on the body and lights up well. As for the dental material, it is still being worked on to make sure that it is strong enough to survive biting and chewing. Also, balancing the amount of antibacterial agent being used is still in the works to make sure that it is not too harmful to the human wearing it. And finally, for the insulin needle patch, engineers are still working on the size and shape of the patch and need to make sure that it is strong enough to endure sweating and showering. And now, I will discuss a few skills that chemical engineers need to perform well at their jobs. Firstly, engineers need strong problem-solving skills to be able to identify problems and be able to create solutions to them. And secondly, they need strong communication skills to be able to work with other engineers and discuss new ideas. And now, finally, 3 questions I would ask a chemical engineer. 1. How difficult is it to keep working when faced with a large barrier in your research? 2. What excites you the most about your job or your research? And 3. Why do you believe your research is important to society or is worth investigating further? This has been my cutting-edge chemistry research project. Thank you for listening.